Grayscale, the ultimate in artsy-fartsy, pretentious and unfairly nice looking Instagram material. But how do we turn color into sweet, sweet gray tone? It turns out to be a stupidly well-researched question. I know, who would have thought? Let's dive into what turned out to be a way too detailed exploration of a question probably none of you asked.
Baby, you give me ice and fire. You're giving me wind and rain.
First, an image consists of a red, green and blue color channel representing the intensity of these colors. By the way, that animation was dope as frick. You can bet your sweet McGillicuddy I'm gonna reuse that. A pixel is gray when all color channels agree on the value. So each of these could be made into grayscale by just replicating a single color channel into the rest. This is perhaps the dumbest way, since for most images the color channels won't all be good looking, and we're in search of peak artsy-fartsy. We'll now move on to the world of only semi-laughable grayscale methods. The first being the much overrated method called value, which is a dumb name since it's just the maximum of the RG and B values in a pixel. And maximum is a hella more dope name than value. Now I'm gonna need you to ignore the cases that actually look good, as value has no business looking good. A lot of the time value has a strong bias to the bright side. Now I know what you're thinking. If we can use maximum, then what about minimum? Different to the value method, this is actually certified pointless, being used like never. But that's in our favor, because at least it's unique, which is kinda synonymous to artsy-fartsy, I guess. It does, however, bias strongly to the dark side. Trying to ride the line between the dumb maximum and the pointless minimum, we can take the value that was neither maximum nor minimum. You know, the middle child. This is called median, and is a bit of a basic bitch. Another way to go between maximum and minimum is, and hold on to your socks because this is gonna get unnecessarily complicated and not less brain dead. You take the maximum and the minimum and then you average it. Why don't you just take all three channels? And what the fuck did median do? Who hurt you? Now I'm not making this up. This is an established grayscale method named luster. And it's way more popular than median. Comparing luster to median, we most often see higher dynamic range in median, #HDR material. Feel free to pause the video and judge for yourself, and while you're at it, give it a like if you agree, and if you disagree, you can call me an idiot in the comments. But sometimes average stupid beats middle stupid. But then again, it's all stupid on this side of the table, so let's flip it. Again, feel free to pause and judge, and this time, let's say hit a like if you disagree and comment if you agree. #maximum cares. Now one or two of you are probably screaming to just take the average of all channels, red, green and blue. And I'm with you, keep it simple, stupid. And we're not the first to have this strike of genius. This is called the intensity method. Now this is in the category of methods using all three channels, which is not necessarily amazing, but it's a lot less stupid than the previous ones. I'll name these simple-minded. Now, there's the issue of very low dynamic range, as the average has a strong bias towards the middle, which is kind of like some Polaroid shit. And that shit's hella artsy-fartsy, but you can't deny it's a bit ugly-buggly. Instead of just doing a normal average, we can add weights to the channels. The most popular set of weights are 0.2126 for red, 0.7152 for green, and 0.0722 for blue, which was decided by some smart peeps that noticed we don't see the colors as equally bright. This is perhaps the most popular method, and it's called luminance, only rivaled by lazy people using the intensity method, giving green far more impact than the others, sometimes deals with the low dynamic range issue from intensity. And let's just ignore that for many images it makes zero visible difference. A cheese to improve dynamic range is the gamma correction. You take a channel and for each pixel value you raise it to a power. When the power is greater than 1, the middle values are darkened, and when the power is less than 1, middle values are brightened. Usually the power 2.2 is used, which removes a lot of the brightness in an image but leaves the highlights. Needless to say, this is popularly applied to all simple-minded grayscale methods. Applying it to the color channels in the intensity method is called gleam, which feels like someone needed to balance the great performance of the method with a dumbass name. Write ideas for a better name in the comments. Because I blame the lack of usage of this method on its borderline icky name. Even though luminance already has a bit better dynamic range, won't stop us from applying some sweet gamma correction to it, and this is called luma. And it's definitely not always better than luminance. Sometimes gamma is not exactly what we need, as it is unidirectional, meaning it will move values either darker or lighter. This can improve dynamic range, but will often have a darkening or brightening effect. Often you could be better off with a simple piecewise mapping, moving some values brighter and some values darker, thus being bidirectional. This will be way more effective at improving dynamic range while controlling brightness, but that's a tangent for another video. And that's it for the video. Now I give you some cheek-slapping grayscale images.